Hi, I'm Ian Griffiths, and this is a talk from the Building Silverlight Business Applications series. In this talk, I'll discuss MEF, the Managed Extensibility Framework. The example application we've been building in this series of talks, the Event Manager, has an administration dashboard that needs to be able to send email. But we might want to support different mechanisms for sending mail. Using Outlook might work fine for small-scale events, but for some situations, you'd want an email assistant designed for a larger scale. So we really want pluggability here. We want to be able to support multiple different mechanisms for sending emails. We could do this by using Silverlight 4's support for the Managed Extensibility Framework. MEF is an API for dynamic component composition. It can be used in a number of ways. It can support plugin systems. It has various ways of discovering and loading dynamically choosable bits of code. It's also useful for applications built around a model of a simple central shell into which various components are added. Visual Studio works this way. It has no intrinsic idea of what C# or VB.NET are, but can load language services dynamically. Features such as the Solution Explorer and Data Sources windows are also dynamically loaded pieces. The basic shell of Visual Studio itself does relatively little, with pluggable services providing most of the real functionality. And Visual Studio 2010 is based around MEF. Our use of MEF in the context of the example application will be a bit more modest. We're using it to open up the possibility of using multiple different email providers. We could also use its dependency injection features. MEF isn't designed as a dependency injection framework, but it needs to be able to support basic DI operation because of how it works, so we could use it as a mechanism for wiring things together, such as connection views to view models, while minimizing dependencies between components, thus promoting testability. To use MEF, a component can declare either imports, exports, or both. An import is a declaration that this class relies on a service provided by some other kind of component to work. An export is a declaration that this component provides a particular kind of service. So the code snippets here show three ways of declaring that we need an iEmail sender. You can import either via properties or constructors, and properties can declare that they accept multiple items, which is what you can see in the third example here. The fourth snippet shows how to declare in some other class that we provide an iEmail sender. The hosting program then has various options for arranging for the imports and exports to meet. The process of connecting components together by resolving imports and exports is called composition. This is managed by a class called composition container. You can create your own composition container explicitly if you want, and this can sometimes be a useful thing to do in unit tests. But most code will just use the single process-wide default container. Components normally use this by calling the partInitializer.satisfyImports method. This says, I'd like the default container to try and provide components that export all the things that I import, please. As the application author, you can provide the default composition host. If you don't supply one, MEF will generate one automatically, and the default host uses reflection to discover exports in the main application assembly. But we can control where a composition host looks for exporters by providing a catalog. MEF defines an abstract base class called composable part catalog, which represents something that can find exporters on behalf of importers. There are several concrete catalogs built into MEF. Assembly catalog searches all the types in a particular assembly for suitable exports. Type catalog lets you provide specific exporting objects directly. Aggregate catalog lets you combine multiple catalogs together. For example, you might want to augment the default reflection-based behavior rather than replacing it entirely. So you could create an assembly catalog to reproduce the default behavior for your main assembly, and perhaps also create a type catalog to provide some additional hand-configured exports, and then combine these with an aggregate catalog. The ability to aggregate catalogs into a single catalog is necessary because the composition container expects to be able to refer to a single catalog for all its needs. Finally, the Silverlight toolkit offers a package catalog which will search every assembly in a particular ZAP, and it can even download the ZAP in question at runtime. The Silverlight toolkit provides two classes for dynamically loading components with MEF. Note that these classes are currently in the experimental band, so be wary of writing code that uses these. It's likely to have to change in the future, but the API as it stands now is pretty straightforward. The package catalog provides very similar services to the default composition container because it can locate all the exports in a ZAP. The big difference is that it's not limited to the Zap for the running application. You can point it to other Zaps which it can download at runtime, and you can then dynamically compose the results. So this makes it possible to build a MEF-based application that loads components over the internet at runtime. To use the package catalog, you need to use the package class. A package object represents a Zap file. Package offers a static current property to represent the Zap for the running application, and it offers a method for asynchronously downloading other Zaps. Just specify a URL, and it'll invoke a callback when it's finished fetching the Zap. You can then provide a package catalog with a list of all the packages you want, and then pass that catalog to the composition container. One popular application of MEF is dependency injection. A view can declare in the code behind that it wants a particular view model. This means that the view need not be responsible for constructing the view model. That can be useful because in some applications there's non-trivial work to be done when setting up the view models. They might need to be connected to one another, they might have their own imports that need satisfying, and it can be problematic when view classes try to do this for themselves. It can cause exceptions at design time, making the UI impossible to design in Blend. Having said that, the simpler approaches are sometimes better. A problem with dependency injection is that it can sometimes make code very hard to follow. It's often not clear from looking at the code what sorts of objects you're really using or how they came into existence. So although this is a popular technique, it's not without its problems. While we can use MEF for connecting views to view models, that's not the main goal in the context of our example Event Manager application. MEF makes more sense there as a means of making email provision pluggable. Now, MEF has a fair few moving parts, and so does our example application, so to keep the next demo simpler, we're actually going to use a different application. The principle is exactly the same. We're using MEF mainly for pluggable services, and we'll also use it for some view model composition. But by keeping RIA services, data grids, and navigation out of the mix, it'll be easier to focus on the details of MEF. So here's the example application I'm going to use to illustrate MEF. On the left here, we have a list of probability distribution functions. This one produces an approximately triangular distribution, and this one produces an approximately rectangular distribution. And this application is using MEF to discover and load and use the objects that provide these distributions. And this is an extensible application because, as we're going to see, it's possible for the thing to load other distributions dynamically, even from external Zaps. So let's take a look at the code. Actually, to start with, I'm going to show the code behind file for the main view here. So this distributions view provides the basic layout for the user interface. There it is. If we go and look at the code behind, notice that we've got this public property here of type distributions view model with an import attribute. And remember, the import attribute tells MEF that this object is expected to be provided with an instance of this class in order to function. So something somewhere is going to be hooking this up to the view model. And if we look at the view model class itself, the distributions view model, this is marked with the export attribute. Now, normally, exporters declare what type of thing they're exporting. It's most common for an exporter to say, I export this interface. But in the case of our view model, well, we've not bothered to define an interface. The view model is just the view model. So if you don't specify a specific interface, it assumes the thing that you're exporting is yourself. We're simply declaring that we are open for business via MEF. So that's what will happen here. When MEF ties things together, it's going to hook things up by plugging an instance of that view model into this property here of the view class. So what actually hooks everything together? Well, if you look at the main page.xaml, this contains an instance of that user control, the main view. In fact, that's pretty much all it contains. If we look at the XAML for this, the only thing in there is this one custom user control, my distributions view. And if we look at the code behind for the main page, you can see I'm using MEF here. I'm using the composition initializer satisfy imports method. This uses the default process-wide composition container to satisfy the imports of that user control. That will then go and look at the user control. MEF will find this import and go, oh, I've got to go and find a distribution view model now. And because of the default catalog, which reflects against all the stuff in the Zap, it will find this export and will instantiate that. And then it will find that this has its own import. Now here we're using a slightly different form of import. We're using the import many attribute, which says, well, this property expects to be given some stuff by MEF, but it also is happy to be given multiple objects. This is where the probability distributions get added by MEF. And remember, I already have two of those things. I've got the rectangular distribution and I've got the triangular distribution, and I'm going to be adding more. So this property declares an IEnumerable to say that I'm happy to have multiple items, and I'm going to import many of them. Now, the code is a little bit complicated. Rather than just saying IEnumerable of some interface, and iGenerator is the interface that this thing expects to be given, it's a little bit more involved than that. We've got this lazy, we've got this iGenerator, and we've got this iGenerator data. Well, let's look at those two interfaces first of all. If we go to the definition of iGenerator, which I've actually put in a separate library, I've got this probability distribution library here that defines this interface because I want to have multiple projects refer to it. My main project's going to use this, but also I'm going to have an external project that provides additional generators to be loaded at runtime. So this library defines iGenerator and says, well, things that want to provide random numbers based on some particular probability distribution must implement this interface and provide a generate numbers method, which will produce some number of random numbers settled around a particular mean with a particular variance using whatever probability distribution this particular generator supplies. So the view model is expecting to be provided with one or more of these iGenerators. What's the iGenerator data about? Well, MEF lets you define what's called a metadata interface. This is an interface which kind of relates to a particular export, but provides information about the export. So in our application, if I run it one more time, this list over here, which shows all the distributions, well, we know where these numbers are coming from now. These are coming from the iGenerator implementations, but where are these names coming from? Triangular and rectangular. Well, we could have put a display name property in the iGenerator itself, but the idea of information about a particular export is abstracted into this metadata idea with MEF, and you can define a separate interface called iGenerator data, and it's named from the base interface with data stuck on the end, typically. And the significance of this is we don't actually have to implement this interface directly. MEF will provide the implementation of the metadata interface, and we simply have to provide the metadata itself, and it will then make that available through this interface. And we'll see exactly how you provide metadata in a moment. So we've got these two interfaces. Let's go back to the view model, which expects to be provided enumeration of generators and associated metadata for generators. What's this lazy thing about? Well, if you put that in here, this says, well, I want to know which generators are available, but I don't actually want you to instantiate them until I ask for them. So rather than giving me back the iGenerators directly, it gives me back a lazy of iGenerator data, and it's only the point at which I actually ask for the generator that it will go ahead and create it. So I can collect all the metadata, and this thing goes through and builds item view models out of that to work out what to display, but the generator is loaded at the last possible minute. Now, most of the rest of this view model isn't particularly interesting. It just does the work necessary to populate the UI. It's lots of kind of observable properties and a little bit of work to do the histogram plot of the probability distributions. So it's not particularly interesting as far as MEF is concerned. So the next piece for us to look at is a couple of the generators themselves. So here is my slightly shonky rectangular distribution generator. So it implements the iGenerator interface. It declares that it exports that interface. So when MEF finds this, it goes, oh, I know this is actually deliberately exposing this interface because it wants to make it available to MEF parts that import that type. It doesn't just assume that because you've implemented this interface that you necessarily want to export it. You have to be explicit about the fact that you're a part exporting services. And again, the actual implementation is not that interesting. I'm just using the built-in random number generator to generate a flat distribution. But the other interesting thing here is this export metadata. This is how we populate the metadata. So I'm saying I would like MEF to provide an iGenerator data implementation for this part, and I'd like it to make the display name property of that interface. If we go back and look at the interface, it's display name there. So this thing is saying when MEF implements this interface, the value it should provide for display name, in this case, is rectangular. And that's how the metadata interface is getting populated. That's how the UI is showing a list of suitable items. So we're using MEF to hook up the view model. We're using MEF to populate the view model with a list of generators. Now, the next thing I'm going to do is bring in this external generators project. I've got a separate Silverlight application here, and it's a full Silverlight app. It's got the app and the main page, but actually we're not using those. All I really want here is a compiled Zap, and the easiest way to get Visual Studio to give you that is to use a basic Silverlight template, and things stop compiling if you remove the main page and the app. So I've left those in there even though I'm not really using them. What I really want is a couple of classes, 2 more distributions packaged up into a Zap that can then be put somewhere up on the website, and I've chosen to put these both in the client bin. So MEF demo, that's my main application. External generators, that is the other Zap that we're building. And this contains a couple more distributions. So a Pareto distribution, and again, the display name and the exports and so on, and also a Gaussian distribution. So these are external, they're a separate Zap. And what I want to do is download that Zap at runtime and then compose that into my view model along with all the other stuff. So I'm going to need some slightly different code in the place where I actually kick things off with MEF. So right now, I'm just using this basic piece of code to say I'd like to use the default composition host. Well, now I'm going to have to tell the composition host I'd like to use a different catalog than the default. So I need to download the Zap, build that into a package catalog, incorporate the local Zap as well, and then provide all of that. So the first thing I need is the URI to my external package. So this is going to be near our existing app. So I'm going to say, well, where is my current application's hosts source? That's the URI from which this Zap was originally downloaded. I'm going to say, well, relative to there, please find this item, external generators.zap. So I'm basically saying, well, I know I'm here, so please go look next to me for this thing here. Then I'm going to ask the package class, and this, remember, is provided by the Silverlight toolkit. This is a feature that represents a Zap, possibly the local Zap, or possibly one we've downloaded. I'm going to download one, and it will do an async download. I give it the package URI I'd like it to download, and then give it a callback function. So in here, well, I'm going to first of all build a package catalog to say, well, this is the catalog of stuff I want to make available for MEF. Let me actually give that a name. It'll work better. So remember, catalogs are the abstraction in MEF. They are the thing that says this is a service that knows how to find providers of exports that can resolve the imports of other components. So I'm going to say in this catalog, I would like to add the package we just downloaded. So the package is passed as an argument to the callback that I passed to this download method. So I'm saying, please make everything in there available. And also, obviously, I want to add the current package. So this is the executing Zap. This is my main application. So in other words, this basically means all the stuff I would have got from the default composition host is going to be available to me. And then I say to the composition host class, I'd like to initialize you with this catalog. You only get to do that once. If you try and initialize it more than once in the lifetime of a process, you get an exception the second time you try it. But we're loading the main page, we know we're going to be first, and I'm in charge of the application, so I know this is a suitable time to call that. And then finally, I can actually use pretty much exactly the same code I had before to satisfy the imports of my distribution view. So that is the same as it was before, but I've now reconfigured the default process-wide composition host. So let's try running this again. And now I get 4 distributions. I get my original triangular and rectangular ones, but I also get a Gaussian distribution and something sort of approximating a Pareto distribution, a power law. So Still using MEF, I didn't change any of the code in the view model that goes and looks for these things. All I did was reconfigured the composition host to go and download stuff dynamically from an external Zap, and that Zap got loaded into this particular Silverlight application, and it was then able to use the additional iGenerator providers, the additional exports that it found in that Zap.